Susan Poss. I am working today in section 10.5. It's a very long section and there's a lot of material in here, so I'm going to split it up into several shorter videos. This first part of 10.5 I'm going to actually split up into 6 short videos. Okay, so we're graphing quadratic functions. Previously we've been solving them. We solved by factoring, we used the square root method, we used completing the square, and we finished up by using the quadratic formula. So now we're taking some of those same functions and we're going to look at the graph or the picture when you plot points. So the first one we're going to look at here is the graph of f of x, and I hope you're noticing and are familiar with how I'm reading this. F of x. F names the function, so this is function f, and x is called the argument, and that is the input or the independent variable. So you'll see me substituting in for x. All right, so let's go over here and plot a few points first, and then we'll try to answer some of the questions. So I've created a little table, and in the x column, the first value that you see is -2. So I'm allowing -2 to become the argument. And so when I do the arithmetic, when x is -2, y is +4. The next value I have in my table is -1. And when I square -1, I get +1. So the next point is -1, 1. When I substitute in for x with a 0, I get 0. And here's where you begin to see something called symmetry. So there's a repeat on that y value, and the last one I have here is f of +2. I'm substituting in with +2, squaring that, and getting +4. So you're beginning to see here what's called symmetry. So things look like they are symmetric around that point 0, 0. So let me go over here and plot. -2, 4 is right about here. -1, 1, 0, 0. +1, 1. +2, 4. So when you graph this type of quadratic equation, second degree equation, you get a shape that we call a parabola. There. This parabola opens up. The two ends are pointing up out the top of the graph. So the vertex on this one, we also refer to that sometimes as the turning point. And later on you'll hear me call that the minimum point, because it's the lowest point on the picture. So the vertex here, we're going to write down the coordinates. 0, 0 is where the turning point or the minimum point or the vertex is located. And the axis of symmetry is what I call the fold line. It's the line about which the parabola is symmetric. So you can see back in this direction and this direction, you can see that we have some balance or some symmetry to this. Axis of symmetry is always an equation that begins with the letter x, and in this case it's running up and down the y-axis, so all the x coordinates up and down the y-axis have a value of 0. So that's what I'm going to refer to as our parent. You'll hear me call this the parent. The basic y equals x squared, or f of x equals x squared. So what we want to do with these is explore what happens as you begin to change some of the numbers. So now instead of having the function f of x equals x squared, it says x squared plus 4. Again, you see I have some numbers out here. It's the same set of numbers. So when I plug in with an x value of -2, I get a y value of +8. -1 squared. You always have to do the squaring first. So when x is -1, y is 5. 0 for x. So when x is 0, y is 4, and then we have 2 more, and this is again where we can start to see the symmetry, the repeat. So when x is 1, y is 5. And the last one I want to do quickly here is when I substitute in with the 2, square that, and add 4, I get 8. All right, so it's just a lot of arithmetic, kind of tedious arithmetic actually, but let me go over here and plot those points. -2, 8, 1, 2, 3, 4, 5, 6 is right there. -1, 5 is right here. 0, 4 is right there. 1, 5, and you see the symmetry here, and 2, 8. So again, here's the basic shape, only now instead of bottoming out at the origin, 0, 0, it bottoms out at the point 0, 4. So my vertex here is right there. And remember, the axis of symmetry is the fold line. It always runs vertically right through the vertex, and it always is an equation that begins with the letter x. So what happened with this one? Because we had this +4 in here, it took all of those original values that we had on the parent. Let's go back and let me show you, let me remind you how the parent looked. The parent looked like this. So it took all of those original y values on the parent and shifted vertically 4 units. So you're going to start to watch for that pattern. We're going to call that a vertical shift of 4. So here's kind of a summary here. If you have the basic function x squared, you know it's going to look like a parabola. And then you're going to look out here and see if there is a number out here on the end. If k is positive, the graph shifts upward. If k is negative, the graph is going to shift downward. And the vertex is always at 0, whatever that vertical shift is. And the axis of symmetry is always going to be the y-axis. So we're going to do some real quickly here without plotting a bunch of points like we did before. So I'm going to just roughly sketch in real quickly here what the parent looked like. Remember, that's our basic starting parabola, so there's the parent. Now the one in pink, g of x, the name of the function is g, is going to shift up 3 units. So the vertex is going to be here. And you can see that the parabola, all I did was just take every point and shift it, transpose, translate, move it upward by 3 units. So that one has a vertical shift of +3. The vertex is at 0, 3. And the axis of symmetry is at x equals 0. Again, here's the axis of symmetry running right up and down the y-axis. Okay, on the next one, you see that it has a -4. So again, let me quickly sketch in the parent. Looks like that. I'm not doing a real great job of sketching, but hope you can use your imagination. And on this one, I'm going to take that vertex from 0, 0 and shift it down 1, 2, 3, 4, and try to sketch in those same points again, and then sketch in the parabola. So the vertex this time is at 0, -4. The axis of symmetry is still at x equals 0. So we're going to call that a vertical shift of -4, or down 4 units. All right, so it looks like that's where I wanted to stop for our first exercise in learning how to graph these.